Great. Then I can explain to you what it is. All right. So, let me introduce myself. I'm Kajari. I work at Mapbox on the directions team. And our directions APIs are powered by OSRM, so I get to work on an open source tool at work, which is great. Okay, so OSRM stands for the Open Source Routing Machine. And it's the open source part we all know. The machine does things repetitively. And the routing, so when I'm talking about routing here, I mean on roads. And this is usually the output that I think of when I think about routing. You give it a start point and an end point, and it'll give you the path on how to get there, and maybe some steps on how to get there. And maybe you even have a phone that will give you step-by-step instructions on how to get there. And usually how it works is you have some data that you provided, and in this case it's OpenStreetMap data. And you give it to the router, which turns it into a graph that it can route on and search on. And then you ask it to do something like get me from point A to point B, and it'll spit out a result that you then put into a user interface to make it look pretty. So let's look at some cool use cases and some cool interfaces that you can put it into. In this scenario, the driver is choosing where to go to drop off the hamburger or pick it up. I'm not quite sure, but they're painting the route. And so this is just a simple route that it's drawing. And you can also, this video is a bit cooler, so we're going to watch it this way. You can overlay the directions in an augmented reality sort of app, and add all of this extra information to where you're driving on. So hopefully in the future that's what you're using and not just a phone. Yeah. Okay, and then this is a third use case. This is more about trip planning, and it's how to efficiently, pick up your tacos, drop it off, and then pick up your pizza. And on the right, you can see a website, but then on the left, it's showing you the turn-by-turn navigation. Cool. So those are some very cool user interfaces. So let's get back to the routing portion of this. We're still trying to answer what the OSRM is. And it's the middle part, it's the router. And it generates a graph and performs calculations. And the calculations it performs are usually searching the graph in a particular way to get a particular type of answer. So OSRM is a library that you can plug into an application. So your phone app or your website, we run it on a server and then have an API surrounding it so people can make requests on servers. The output is JSON. Yeah, and it's a C++ library. I think that's what's quick enough. But you also have to provide it data when you put it into your application. Okay, and if you wanted to get started, you could go to Project OSRM, and it has a demo as well as documentation. All right, so let's look a little bit more about these two things, so generating the graph and searching the graph or performing calculations. So to generate the graph, we need to know what the graph is. And this is Dar es Salaam, and that's the road network. We zoom in, find a very clear grid-like road network. And this is an OpenStreetMap. And you can see that each of the intersections have turned into nodes, and each of the roads have turned into ways. And you could think of that as vertices and edges in a graph. And each of the edges have a weight. And the weight depends on a number of things. It can be the distance, or it is partially the distance, it's partially the speed. There's some penalties from having to turn that get applied, as the type of road affects all of these things. It's a combination of different factors, and you can add traffic in there. And that affects how you can route on the graph. So, okay, so now we know what the graph is. Now we want to generate the graph. And generating the graph is motivated by how you can search the graph. What you want to do is you want to search the graph quickly. Now, the classic search algorithm is Dijkstra's search algorithm. And it works by, if you're getting from the bottom point to the top point, what it will do is it will look at every single node. So it'll start off at one of the points, say the bottom one. It'll look at every node that that bottom point is attached to. Then it will look at every node that each of those nodes are attached to. And it just like very slowly, methodically searches every single node of the graph. So this is obviously very inefficient. If you're trying to get from Dar es Salaam to, I don't know, somewhere in Ghana, you're going to have to cross the entirety of Africa, and there are a lot of intersections on the way. So what you do, oh, well, wait. Okay, so it goes out in a circle, and yeah, and this is just like showing how many nodes you would have to have touched before you ever got to your endpoint. So the answer is shortcuts. You just don't go through the whole graph. Or, well, when you're creating the graph, you can figure out which roads will be widely traversed. So if you're going, you know, from Tanzania to Ghana somewhere, there's probably like a big highway you can use. So you find ways to make shortcuts. And then you use the big shortcutted road, and it's like it's a fake road that you use to use when you're doing your pathfinding. And then when you get closer to the place that you're actually going to, you go onto the full network and then do a shorter search there. Okay, and so OSRM has two shortcut algorithms. One of them is called multi-level Dijkstra, and the other one is called contraction hierarchies. And I haven't gone into them here, but we can talk about them if you want to later. Okay. So now we've created the graph, and we can search the graph, or we can perform calculations on the graph now. And these are apart from tiles, the first one, all of these other ones are what OSRM provides as services. And they all are, not all searching the graph, but a lot of them are searching the graph. Okay, so the very first one, tile, is, it returns a Mapbox vector tile that will show you what sort of pieces of data it looks at when it's making its routing calculation. So this map has speeds on it. They're really small to see. I didn't realize the resolution was so bad. But there are those like white markings by the sides of the road. And this is really cool because you can inspect what your data looks like. Okay, then the second service is called route. And this is your typical use case, getting from point A to point B. You can send requests, or just click on the URL on the right. And what you see there is, first of all, you have the URL, and you have the service, which is route, the version, driving, because there are a couple of different profiles you can use. You can use driving or bicycle or walking. And then you provide the start destination and the end destination as lat long, so long lat. And then some options there at the end. And the result you get back is on the left. At the top, there's routes and then the geometry. And so if you paint that geometry, the line string there, that's what's painted on the picture on the right, and in the map on the right. And if you want turn-by-turn instructions, it'll be in legs and then steps, where I have commented out step-by-step instructions. It's just an array full of every single part of the trip that you need to make. It also gives you some summary information like duration and distance. All right, so that's route. Nearest. So this is one of the ones that isn't search necessarily. You have your location, and that's the Julius Nyerere Conference Center, Convention Center. And that's correct, that's where it is. However, the router is really, really dumb and won't find it because it's not on the road network. So the nearest service will let you pass in a coordinate, and it'll look close by for the nearest point of the road network, and will provide you matches. In this case, it only provided us one match, and the closest match, and it snapped you to the road network. And so this is what you would use if you were creating a driver app, and you said, pick me up here, and before you begin your request, you would snap it. Okay. All right, then match. So this sounds like nearest, but it's a bit different. What it does is it cleans up noisy traces. So you can pass a lot of GPS coordinates, and GPS coordinates are, are a little bit to the left or the right of the road you're actually traversing on. You pass all of the points in, and it'll clean them up and give you a nice line string. All right, and then this is trip, and this is a picture of what we saw earlier, of the video that we saw earlier. Trip is really cool. It's what logistics companies use. So if I'm a FedEx driver and I want to drop off a lot of packages, then I want to be able to input like 100 points, and I want to know the fastest way to get to all of them. And in this case, we're picking up ramen, tacos, and pizzas, and I want to know the fastest way to do it. So this optimizes your trips for you. And it just does it by brute force for less than 10 points, and then after that it uses this thing called farthest distance insertion. Okay, yeah, and then that brings us very nicely to this table. Table is what feeds the trip API. It tells you if you pass in, in this case 8 points, it will tell you the distance from all of them to all of them. So this first one up here, 0 to 0, is because it's a point to itself. And then the next one along that is from, let's pretend they're numbered 0 through 7. The next number would be from point 0 to point 1, and then point 0 to point 2, 0 to point 3, and so on. And so what this lets you do is it lets you feed any optimization that you want to do. So this is a use case for it. Here you can see this is in Peru, and it's the percentage of population now to higher education. The people who live in the green areas have access to higher education, and then like everyone spiraling outwards into worse color, or not worse, but like graduating towards red and then gray, shows you how many people have access to it. And it's all because they're like further away, travel time-wise, from whatever institute they're teaching. So right now it's higher education. There's also financial institutions in there, and I think more people have access to financial institutions. Yeah. And there's healthcare, financial institutions, and education. So this is a use case that the World Bank has created to be able to analyze accessibility in rural areas. And yeah, it's quite cool. Okay. And then yeah, so this is the logistics use case where you can pick up some stuff, drop things off. You have pick up and drop off times. Now, OSRM doesn't do all of this optimization itself, but this is using the matrix to feed all of the calculations that go into optimizing the code. Right. Another thing that you can do with the matrix is isochrones. And so this shows you a map of how far you can drive and on the road networks that exist. Yeah, so this is a visualization of like going from marker 1 to all of the other markers, and then just imagine that happening for every other marker. Okay. So a rundown of what we talked about. We talked about how map data gets converted into a graph on which we do calculations, and then you can send it to a user interface. We talked about how you turn a road network into a graph. Talked about what goes into creating the graph. And then the fact that it's informed by having to search the graph. Most services are based on searching the graph. And then we looked over the OSRM APIs. So what's next? You should go to Project OSRM and start building your own cool use cases. That's the link. And MapBus has a bunch of tutorials that you can use to build on top of the requests that OSRM gives you for visualization. Like all the visualizations here were built with Mapbox tools. So and we have a lot of tutorials that will like step-by-step walk you through being able to use some of these APIs. So yeah, that's it. And yeah, any questions?